Welcome to InterviewPro. Let's solve another LeetCode problem today. Unique paths 2. This question was asked in a number of companies. So let's see what this question is about. We will be given m by n integer array. We'll be starting from the first cell. We need to reach the last cell of this grid. And the condition is we can move only to the right or to the cell below the current cell, and there will be obstacles as well. The obstacle will be represented by an integer 1, and if it's not an obstacle then it would be simply 0. Let's see how many unique paths we can calculate for this first example. Let's try to understand this problem. We will be starting from this position and we need to reach this position. This problem is similar to the unique path problem which we have solved in our previous video. If you haven't watched it yet, please go to the LeetCode playlist and watch that video. Now, the difference between the unique path and this path is there is an obstacle here. So let's try to solve this. What are the two directions that the robot can move? To the right or to the bottom. So let's take this cell. To reach this cell, what are the possibilities? To come from either top or from left. But there is no left to this cell. So the only possibility is to come from the top. So the number of ways of reaching this particular cell is equal to the number of ways of reaching the cell above it. Similarly, the number of ways of reaching this particular cell is equal to the number of ways of reaching the cell above it because there is no left. So as we are starting from the first cell in the grid, let's assume the number of ways is equal to 1 because that's the only way we can start from the first cell, right? There is no other possibility because there are no cells here. So this will be 1. Now to reach this, it would be same as the cell above it. So this is 1. And to reach this cell, it would be same as the cell above it, which is 1 again. Let's take this first row now. To reach this cell, what are the possibilities? To come from the top or to come from the left. There is no top here. So the only possibility is to come from the left. So the number of ways of reaching this cell is equal to the number of ways of reaching to the cell before it. So this is equal to 1. Now this is also similar. There is no top here. So this would be equal to the number of ways of reaching the cell before it. So this is 1. Let's consider this cell. This is an obstacle. So there is no possibility to reach this cell. So this would be simply 0. Now, if we come to this cell, what are the possibilities? From the top or from the left? From the left, it is anyways obstacle, so it's 0. The other possibility is to come from the top. So the number of ways of reaching this cell from the top is equal to the number of ways of reaching this cell, which is equal to 1. So the sum is 1. Same with this cell as well. From the top, there is no path, so 0, plus from the left, we have one way, which is equal to 1. Now coming to the last cell, it can be reached by coming from the top or from the left. So we already know the number of ways of reaching the cell above it, which is 1. So 1 plus, we also computed the number of ways of reaching the cell before it. So it is 1. So the total number of ways is equal to 2, which is coming from this way or coming from this way. So if you look at the output, the number of ways is 2. And what are those two ways? Right, right, down and down. So if this is the first cell, right, right, down and down. Then the other way is down, down, right and right. So this way, this is the other way. Let's try to code this. I'll be coding in C#. In order to store the number of unique paths for each cell, we need a grid. But we already have the input grid, so I'll be making use of the same grid. But in the interview, just confirm with the interviewer if he or she is okay with using the existing grid or they want a new grid. In this case, I'll be using the existing grid only. So what was the first consideration? We are starting from the first cell, so we can simply assign this cell with 1. Let me do this obstacle grid of 0, 0 equal to 1. So for the first column, we can simply assign the values coming from the cell above it for each of the cells because there is no cell towards their left. So let's create a loop in row equal to 1 because the first row is already assigned. We don't need to consider that row. So I'll be starting from the second row and uh, let me create two variables here. Int m equals obstacle grid dot length. Int n equals obstacle grid of 0 dot length. Variable m represents the number of rows. Variable n represents the number of columns. So let's loop through all the rows. Row plus plus. So in the obstacle grid, for every row, we'll calculate values for the first cell. If it is, since we are starting with row 1, this would be our first cell. Here, if if this current cell is 0 in the original grid, that means there is a space. If this is 1, that means there is an obstacle. So if there is a space, we'll simply put the value which was computed for the cell above it. Obstacle grid row of 0. If this is 0, then we'll simply assign the value calculated for the cell above it. Otherwise, we'll put 0. Similarly, for the first row, there is no row above it. So the only possibility is to come from the cell before it. So let's create another loop here, but now it is a column. Let me replace row with col. Now we'll assign the first cell of every column with the value which is equal to the cell before it. So if this cell, this should be 0 comma col. If the current cell is equal to 0, that means it is a space, it's not an obstacle. And what can we do? We can simply assign the value computed for the cell before it. So obstacle grid of 0, col minus 1. If it is 1, we'll make it 0. Now for the first row and first column are computed. Let's see for the remaining cells. Let's create a loop. I'll simply copy this. We'll loop through every row and then through every column of that row. So in this loop, let's say we are at this cell. This cell has an obstacle. So what do? We'll simply assign it with 0. So if obstacle grid of row col equal to 0, we'll compute the values. If it's not 0, that means it's an obstacle. So what do we do that in that case? Obstacle row col equal to 0. Now coming to this scenario where there is no obstacle, what did we do? We computed the value to the left and the value above the current cell. So obstacle of row and row comma col is obstacle of row minus 1. That means the cell above it. And also we need to add value coming from the cell before it. Finally, we'll return obstacle grid of col minus 1 and row minus 1. This represents the last cell of the grid. And one more thing that we did not consider is, what if the obstacle is in first cell itself? That means we don't have any path to compute, right? There is no entry to this grid. So the number of ways would be 0. Let's add that condition as well. If obstacle grid of 0, 0 is equal to 1, let's simply return 0. Let's try to run the solution. Okay, there is a spelling mistake here. Let me update it. Also, this is not a question mark, it's a colon. Okay, this is not row because the row is only for this loop. We can make use of m and n. So m and n. Okay, there is a semicolon missing here. Now let's run this. The solution is accepted. Let's submit it. But before that, okay, this column is should consider n. Yeah. Let's run this. Okay, and submit it. The solution is accepted. Coming to time complexity, we are looping through each and every cell in this grid. So it would be big O of m by n. Coming to space complexity, we did not create any new array here. These are just simple variables and we made use of the existing grid. So the space complexity is constant, which is big O of 1. I hope the solution is clear. If you like the content, please like, share and subscribe to InterviewPro. Thank you.